Welcome to week 4 of the embedded system design with ARM course. So, in this week I will take you to the tour of various microcontroller boards, and specifically I will be discussing about two boards. One is STM board and another is Arduino board, and I will also show you how you can program using these two boards specifically. There are other development boards as well, but in this course we will be taking the opportunity to take these two specific boards into consideration, and will be discussing the experiments based on these two boards. So, the concepts that will be covered in this lecture is like I will introduce microcontroller boards. We already know what is a microcontroller. I will be now discussing about two boards. One is STM32F401 board and another one is Arduino Uno. All the experiments that we will be doing in this course will be based on these two boards. So, let me talk about what is a microcontroller board. We can define it as a standalone development board containing microcontroller, memory and other necessary peripheral I/O components. Why it is used basically? It is used for fast development of embedded applications, and it is generally built on a printed circuit board which is called PCB, containing all the components that are required for the experimentation. Okay. So, microcontroller boards are used for this fast development of embedded applications. Nowadays we see lot of embedded application, starting from, if you think of a small example, let us say a smoke detector. What is it? It is a system that will detect smoke if it is present inside a particular room or a particular area. In that case, what do you require? You require various other input output devices, but more specifically you need a microcontroller board through which you will be connecting a sensor that will read some analog values, which is in terms of, let us say, smoke inside this room, and it will convert digitally to some value and then will do some kind of operation to find out whether there is a smoke inside this room or not. So, that it will detect. Based on that detection, various things could be done. One thing, that a buzzer could be on, and then you can actually hear that sound and you can make out that okay, there is some issue in that particular room also. Or we could have a system where we can directly send the information that yes, there is a smoke inside this room to, let us say, the fire brigade. Okay. We'll look into all these aspects in course of time, but in doing this particular application, that is smoke detector, you need microcontroller boards, and these microcontroller boards are so powerful that all these input output ports are along with it, such that you can actually connect directly with the sensor, with the buzzer, etc., to make the complete system. Embedded system development. When we talk about this embedded system development, this involves two major components. What are those? One is the development board, that is the hardware that is required, and another is integrated development environment. We call it IDE, that is the software. So, basically when we think of designing a system, then these two things are required. We need a hardware, that is the board, but how do we program it? We need to have some software associated with it through which we can program it. So, we will also look into that what are the various kinds of IDE, that is the integrated development environment, that we will be using in this particular course for the two boards. Now, for a development board, when we try to design a system, we always think upon that what kind of development board we should use. So, in that regard, upon which criteria we should select which development board to use is based on the following features. One is the bus type, another is the processor type. What kind of processor we are using? The memory. Memory is one of the vital important parameter that is required for any design, because if you want to really dump a very large program and you have a limited memory, you need to think upon it, how will you do it. So, memory is an important criteria that is to be decided when you develop an embedded system. Number of ports and their types. We also need input output ports, we also need analog ports. So, we need digital ports, we need analog ports. So, we need to also decide upon that what kind of ports are there in that particular board, and the operating environment. Like in some development boards, we use some integrated development environment, we will see that, but for some the compiler is already available online. If the compiler is already available online, we can use that compiler. So, only requirement is that you need to have internet connection, because you will be using an online compiler. So, to compile your code into the development board, you need that particular software basically. So, that software is there in the form of a compiler online. So, you have to use internet to use that particular software. These are some common development boards. The one we will be using is STM32F401 Nucleo board that we will be using. It is based on ARM Cortex M4 and it has got 96 KB of SRAM. So, these are some of the features of STM32F401 Nucleo board, and it has got 512 KB of flash memory. What is the clock speed of this particular board? It is 84 megahertz clock. Another very popular board is Arduino Uno. This particular board is an open source microcontroller board which is based on microchip Atmega 328P. It has got 2 KB of SRAM and 32 KB of flash. It has also got 1 KB of EEPROM. Now, the clock it is having its 16 megahertz clock. Now, if you see the features of STM board and if you see the features of Arduino Uno, you can clearly make out that STM is much powerful as compared to Arduino. You see the kind of memory it is having, 96 KB compared to 2 KB, 512 KB of flash and 32 KB of flash. clock speed of 84 megahertz and clock speed of 16 megahertz. Now, I should also tell you one important thing when I am talking about the functionalities. The very important thing is that this does not mean that the application you are running will not run in Arduino Uno and only run in STM. It depends on what kind of application you are running. So, the application which we will be showing in this particular course could be run using both Arduino Uno board as well as STM 32F401 Nucleo board. We can use any one of the board, either this one or this one, for our development. But when you think of a very huge application that you are trying to build which requires higher memory, in that case of course you can see that STM32F401 Nucleo board will be preferred more. Now, there are even more powerful boards, one of which is Raspberry Pi 3 Model B, which consists of quad-core 1.2 GHz Broadcom and 64-bit CPU. Along with that, it has got a 1 GB of RAM, wireless LAN, Bluetooth, Ethernet and USB. So, you can now see that Raspberry Pi model can be used as a computer itself. It has got such a high-end features that can be used for any sophisticated application development. Although we will not be using Raspberry Pi in this particular course, but for very high-end application development, you can of course think of using Raspberry Pi. Another microcontroller board is PIC microcontroller board. So, this is one of the model which is 16F877A. The feature is like this, it has got 8 to 32 KB flash and the clock speed can range from 10 to 80 megahertz. So, when you think of developing very simple kind of applications, then of course we can think of using this PIC based microcontroller systems. Okay. Now, as I have already told you, in this particular course we shall be demonstrating the concepts using the following boards. The first one is STM32F401 Nucleo board and another one is Arduino Uno. Now, there are certain points to note. The process of interfacing and software development for the other boards will be quite similar. As we will be only discussing about STM board and Arduino Uno, you can, if you want to interface any other board, the process will not be very different. So, you can of course do that. But it is important to learn the concept using at least one or two boards, such that you know that okay, we know two aspects of the boards. And what is strongly recommended for this course, unless and otherwise you do that, you will not feel the essence and you will not understand this course to this level. If you purchase at least one of the two boards and perform the experiments using this. So, we will be coming across many hands-on experiments in this particular course. So, we request you that you should go ahead and purchase at least one of these boards and you can do experiment along with us when we show you, if you are interested of course. And I believe that that is the best way to learn this subject. Now, I will move on with STM32F401 Nucleo Development Board. This is the board. This is the board which we will be using. It has got some digital pins, it has got some analog pins, there is a power thing. This is the USB connection through which you can connect through USB. So, let me talk about little bit about this board. So, this board is developed by a company called ST Microelectronics. The CPU inside this particular board is ARM Cortex M4. It has got 512 KB of flash memory which is programmable and 96 KB of SRAM. As I have already told you that this is the USB connector. So, here a USB 2.0 type A to mini B is used. So, here you can connect that particular USB. We will be showing you in subsequent slides how it looks like. So, for connecting from here to your PC, you require this USB. Now, the way we have done programming here using this particular board is embed enabled. So, what we do is that we go to a website that is embed.os.org. I will give you the exact URL for it, and there we actually write the code and we dump the code into this particular board. Okay. And then accordingly you connect through these IO pins or you connect through the analog pins, you can do various other things, but we actually in this particular course we have used this online embed compiler. There is a wide range of choice of integrated development environments. So, you can also use ARM Keil or GCC based IDEs and including IAR. So, that is up to your choice what you will be using, but we have preferred in this course and we have shown through this embed enabled through embed.org. Next, so this is the typical diagram of this board. There is a button, blue color button. Okay, let me, so you can see there is a blue color button out here, that is the user button. This is the reset button which will be used to reset the device. Here is the connector I was talking about, type A to mini B, and there is a red green LED. Okay. So, whenever you will dump a code here through this USB, you will see that this green and red LED will glow. We'll look into all these aspects. Now, there is a green LED here, okay, that is a test LED. There is a red LED which is the power LED which is here, and these are the Arduino connectors. So, these which we will be using are all Arduino connectors, and there are many other ports. You can see these ports. These ports are basically these port or signal connector which we can also use. Okay. So, you can see that apart from these connectors, there are many other connectors that can be used. Okay. But in our experiments, we have mostly used these Arduino connectors. Okay. These set of connectors here and here, we have used those. So, this is the typical broad diagram of this STM board that we will be using. Now at this point there are some points to note. As we know, there are several digital I/O ports. There are also PWM ports, pulse width modulation enabled ports, and there are analog input ports. The digital I/O port lines can be used as interrupt inputs as well. This is already discussed. In more detail it will be discussed later. And for application development through embedded C programs, what needs to be done? You need to connect the board to a desktop or a laptop. That we will be doing. Okay, the first thing first, I have already shown you the USB connector. Through that USB connector, you have to connect that to either a desktop or a laptop. Then you have to open the IDE that is there, and then you need to write the program. So once you write the program in C using necessary driver libraries, those are present, then you can use this online compiler to compile the code. Once you compile the code, this particular code gets downloaded. You can find this in your download folder, and you can then copy that particular code and put it in the device. And I will take you through the tour of this particular thing which I have just told you, but these are the following steps that needs to be followed when you are using this particular STM board. Okay, let us now move on, and I will be discussing about this Arduino Uno development board. So this is the Arduino Uno development board. You can see this. These are the digital and PWM ports. This is the analog ports. This is for the power. This is the microcontroller chip that is there. You can use the USB connector to power it, or you can also use this, you can use through this 9-volt battery to power it, and there is also another one here, sorry. This V-in, basically it can be used to power it. So about this Arduino Uno development board, as I have already told you, it is based on Atmega 328 microcontroller. There are 14 digital input output pins. When we say that there are 14 digital input output pins, that means each of these pins can be programmed to use as an input pin either, or it can be used for output pin. And there are 16 analog input pin. It has a flash memory of 32 KB. It provides an SRAM of 2 KB. It has got an EEPROM of 1 KB and the clock speed is 16 megahertz. Okay. So these are some typical features of this Arduino board. Now let us move on. This is the broad diagram. So as I have told you, this is the USB port through which you can connect to the USB port of the PC. This is the microcontroller that we are using. These are the analog pins, set of analog pins. These are for the power, and if you see, these are digital pins, but some of the digital pins are also PWM. We will look into this specifically, what is PWM in course of time, but this is what is all about the pins of this Arduino Uno. You can see there is also a DC power jack through which you can power this entire board, and as I told you, there is also a V-in through which it can be powered. As I have already told you, there are some other development boards as well, one of which is Raspberry Pi 3 model, which is much more sophisticated. So, typically what it has got, you can see that USB, these have got 2 ports. This is for the network. It can also process this audio and video. So, you have this, and it has got also an HDMI port. There is a micro USB power point as well. There is a display port. You can also put a micro SD in this backside. It is also Bluetooth enabled, and this is the CPU, and this is the GPU, the memory, and these are the pins that can be used. This is all about this board. PIC board typically consists of these pins, and these are some typical features. This is port A. Port A is from pin number 2 to pin number 7. Port E is from pin number 8 to 10, and port C is there, port B, port D, and port C. So, each of the pin has got certain functionalities, and there are various features of this particular pin. So, this is a sample diagram showing PIC 16F877A microcontroller. This is how it typically looks like. Okay? So, these are the pins through which you can connect and you can do programming with. Okay. So, we have actually come to the end of this lecture, and what we have discussed here is basically we have discussed about 2 important boards. One is the STM board, another is Arduino Uno more specifically, but we have also given you an overview of how other board looks like. So, in the subsequent week I will be focusing on the STM board in more details. Thank you.